Welcome to this next video, and in this one we're going to examine the idea of E. Right? Where does E come from and what can we do with it? So clearly I'm not just talking about the letter E in the alphabet, I'm talking about a mathematical constant. So up to now we studied what happens when we take interest in fixed periods that we can count. 1, 2, 3, 4, 5. And we can have an example of that here, if I drag that in from the side. A certain number of periods at 5% interest, 100 euros or yen is your initial amount of money. And then we can track what the investment is worth for each of those periods there, 1, 2, 3, 4, 5. And the amount increases exponentially. Each month there's more in the account, but the amount added each month increases as well. So what we want to investigate now is what would happen if these periods were made smaller and smaller. So perhaps instead of a month, you might choose a week. Instead of a week, you might choose a day. Instead of a day, an hour, and so on and so on. So what we're going to do now is take a look at what would happen if you were to take a standard piece that we've done so far, that 1 plus 1 over m, so this is some figure which represents the ratio, okay, and of course we would raise that to the number of periods. Now in this particular case we're making the special case that the fraction here and this number are related. So what we're going to do is we're going to expand this and see what we get. So let's just start off with period 1, and m equals 1 in this case, m equals 1. We put this into the equation and we get 1 plus 1 over 1, which is 1, to the power of 1. 1 plus 1 is 2, 2 to the 1 is equal to 2. So we get the number 2 coming out of that. And then let's increase that up now. Let's make m equal 2. Our equation becomes 1 plus 1 over 2 to the power of 2. So that's 1.5 squared, which is 2.25, 2 1/4. I will do one more just to start noticing something happening. So if we choose, say, 5, and we go 1 plus 1 over 5 to the power of 5, we get a different number. We get 2.48832. And the thing to notice here is that this gap appears to be getting smaller as we increase m, okay? And if we follow that pattern through, if I move that up, I've already completed this in Excel. If I just bring in some results here from Excel, this is what happens when you continue that expansion. M there, 1, 2, 5, 10, 100, 1,000, and so on. And beside it is that calculation, 1 plus 1 over m to the power of m. And you can see here that the number that you get eventually flattens out. It reaches a limit, okay? And that limit is 2.71828. And this is a number which is very important in mathematics. It represents the limit when the changes that you are making are small and happening continuously in effect. We can make m as big as we like. So this number here appears to be a limit in the universe that we've got, rather like pi. It's one of these numbers that goes on forever without repeating. So this number here is called E, and it somehow represents the idea of a continuous change happening. Okay, so that's what E is, and in the next short video we're going to start looking at what we can use E for in the context of our financial and economic mathematics that we're learning. All right, so E is just a number, it's a constant, and it represents the idea of continuous change in an compounding system. Okay, that's the end of this video.